I'm here at the Ice Age section at our Creation Discoveries Museum. And right here is a demonstration of an ice age. Now, what do I mean by an ice age? We actually found fossils, mammoths, of an ice age. In 1996, we were looking for fossils in the Peace River in Arcadia, Florida. And we located, on one of our trips, we located a tusk this big. Greg Reuter was the one that found it. It was sticking out of the water. We had about 2 feet of water, maybe 3, and it was just sticking out, maybe a couple inches. We all passed by it thinking that at the end it was a piece of wood or a part of a tree. But Greg had a very careful eye and was able to distinguish that there was cross hatchings at the end. And so he stopped and he started to move his hand down and realized this thing continued. And so he moved the sand, because that's what we were digging in, sand. And we moved the sand down. He kept moving it back, digging a little further deeper. And before you know it, he picked up this 60-inch tusk. We were all amazed, every one of us. We were all, our mouths were open. We couldn't believe that he picked this whole thing up. Right close to it was its teeth, the mammoth's teeth. So the mammoth's teeth were in the jaw. We believe the top jaw had fallen out. And there's several specimens. Also, we found the tusk, the end of the tusk. So you could see this beautiful specimen. But that's not all what we found. In 1996, we continued. Greg and his party and others continued and went on the bank, which is a few feet away, and found a mandible, which is the lower part of the jaw of a mammoth. And this is a perfect find, because everything is complete. The teeth are in place. It was a juvenile or a teenager, because all the teeth were not formed. There were rows of teeth that still were in the back and needed to were formed. So we knew that this was a juvenile mouth of a giant mammoth. And we associated this mammoth, juvenile mammoth, teenager kind of mammoth, mouth belonged to the tusk. And so we started to assemble this and put it together. And before you know it, we found more and more fossils on the site. We call it the Greg Reuter site in the Peace River. This is one of the reasons why we look at this kind of unbelievable find and find that this is a testimony that there are animals here in Florida, in Arcadia, which is the western part of Florida, in about 30 miles in, where we were able, from the Gulf, where we were able to find these kind of fossils. Now these fossils come from, we believe, a Columbian mammoth, not a woolly mammoth. This is a woolly mammoth. This Columbian mammoth tends to be large, bigger than the woolly mammoth. Columbian mammoths were more husky, more robust than what we see to the elephants today. This mammoth would be about 12 feet tall. In other words, it'd be the size of an African elephant, the biggest elephant you could see in the zoo. So this was a juvenile. Gives you a hint at how big these creatures would have grown. So we call them Columbian mammoths because they had a different structure. They were bigger, they were more robust, and they definitely had a occupying area in this area called the Peace River in Bone Valley. This mammoth's jaw, the lower part of the jaw, the mandible, was found close to the tusk. And as you look back, as you look at the teeth, you'll notice that the teeth are being pushed forward. We can judge an age of a mammoth by looking at its teeth and the structure of the teeth. So this mammoth, because there's teeth in the back moving forward, this mammoth was fairly young, maybe a juvenile, teenager, 12 foot tall, size of the largest elephant today. So we get a kind of picture of this Columbian mammoth kind of age, and yet had still time to grow. We're at the Ice Age section of the Creation Discovery Museum. I am standing in front of a jaw of a mammoth. Now this is a small jaw of a Columbian mammoth, and we believe it is from a young juvenile, very young. We have its top mouthpiece right here, upper jaw, its mandible, And over here we have, I'm sorry, it's maxilla, and over here we have the mandible, the lower part. And it's a perfect match. It indicates to us very clearly that we found a herd of mammoths on the Peace River in Arcadia. Now, as we move about, we have other mammoth bones that we'd like to show you. These mammoth bones basically are the mammoths that we've discussed earlier. This is the first find. This mammoth here has a femur that attaches all the way to the hip bone. And we have some hip bone bones and so on other displays. But you can actually see the spongy material. You can see the size. Measuring the size, we can figure out, also with its skull and the teeth itself, indicating that it was kind of a juvenile. It was about 12 foot tall. So that's what we're dealing with. Now, above it is our third mammoth. Now remember, we're talking about a herd of mammoths. That was our fourth, the one with the little jaw, the baby. So this is the third one. And this is, look how big it is compared to this one here. So this one was probably an adult. And the adult, believe it or not, its joints were not fused, so it could continue to grow. So when we look at this big femur, we see the femur hooking into the pelvis, and the ball with the ends, where the epiphysis at the ends of the bone, were still open for growth. So this was continually growing. And here we are, maybe 17 foot plus on this great big Columbian mammoth. Now, as we move further down, we're going to take a look more of these long bones, and we'll see that the long bones themselves, here's the humerus. Now this is from the first mammoth. This would be maybe the front legs. This would be the back legs. So we have part of this. We have other parts of leg bones, but these were very well preserved. You can see that they're pretty well complete. Now on top, we have the tibia. The tibia matches this bone here, the femur. So the tibia is from the third mammoth. And you can see the size of that. That's a shin bone. So our shin bone maybe is that big. Take a look at that shin bone. Just gives you a good size of what gigantic size this mammoth could have been. Now while we're here, I want to just explain to you where we think the Ice Age came from. There are many different models. There are maybe hundreds of models, people talking about how this came to be, many different Ice Age. We believe there was one. We believe that this Ice Age came after a worldwide flood. You see, there are two conditions to have an Ice Age. One, you need temperature to go down. And the average temperature of the world should have gone down at least 10 degrees. And we look in terms of the world itself. What would cause that? Well, let's take a look at Noah's flood. We know that Noah's flood took place in the Bible. And it took place, as we read chapter 6 and chapter 7, we know that waters came about. And these waters flooded the whole earth. We know that Noah had 120 years to bring those animals together, to preach the gospel, to people to come and join him on the ark. But many refused, of course. They all refused, except his family. So we know the story that all the animals went in the ark. For about a year, the ark laid in the ocean. And then after the flood receded, the animals were able to move about. And we believe that these mammoths were moving about. The flood would literally cause the waters to heat up because of the opening of the oceans and the heat being produced because of the volcanic action. Volcanic ash would have been surrounding the planet, and so decreasing the temperature to 10 degrees that we needed. The heating of the oceans would have caused evaporation to take place, evaporation causing water to go up, water into the atmosphere coming down in the form of precipitation, making snow. So there are the two conditions. The flood could easily produce those two conditions, making lower temperatures by the volcanic ash and producing water because of the evaporation taking place because of the oceans being hotter, causing a lot of energy in the universe and the earth to dissipate. Now, Michael Ord produced this model, and many creations follow this. And we believe it's a good model because it makes good sense to us. Now, as we go a little further, I'd like to share with you a great big bone. So I'm going to pull it out of its stand. This is the bone of the femur that we just saw earlier laying down. But this is a replica, and I wanted to share with you what size this would be compared to us, to a human. I'm close to 6 foot tall. Get a picture? That had been a huge, huge animal. This is the femur of a Columbian mammoth. It stood at least 17 foot tall. This is a wonder to display. And again, you could see the bone, this beautiful display here. This could show you that the epiphysis is still open so that bones could continue to grow. Could this 17-foot creature get larger? That's a good question. So Johnny, this is yours? I'm here at the Ice Age section at the Creation Discovery Museum. And in this section, I really enjoy looking at the mammoth bones. Over the years, as I suggested, as we talked about earlier, 1996 to 1999, we actually were digging up mammoth bones. And as we found one mammoth, we found another one. And we found another one, and another one. And so what we have here on display in this museum, in this area, is basically how the fossil site looked like. It was about a 30-foot area, and in that 30-foot area we had bones of all different mammoths scattered about. The first mammoth that we found, we recovered at least maybe 40% of it. As you look at this diagram, you can see it. We call this R1 for Reuter 1. He was the first one to discover that mammoth, the bones that we showed you earlier. This is the mammoth, the first mammoth, the juvenile mammoth. And you can see that we have the lower mandible, the tusk, we have the ribs, we have the humerus and femur. So we have quite a few bones. We got a good idea what this mammoth might have looked like. The Columbian mammoth, the juvenile, the teenager. Now, in this display, you're going to see a mammoth, a second mammoth. And what we found in this area, in the 30-foot radius, we found a beautiful articulated backbone skull. You could see, not the skull, but the vertebra. You can see the vertebra upon each other in a beautiful display. Now, the vertebra of the second mammoth, this is the second mammoth, you can see the typical size of the vertebra, pretty big. You can see where the vertebral column went through. And of course, they had these big spines that went up in the air, continuation of the vertebra. And the bone would support muscle tissue, because this one, we believe, could have been maybe 15 to 16 foot tall. It represented an adult. And so we look at this mammoth as an adult, the other one a juvenile, and then we found another baby one. And so we see this kind of herd mammoth find in the Peace River from 1996 to 1999. As you look at the fossil display behind me, you can't help but think, if we had 2 mammoths, 3 mammoths, 4 mammoths, we had a herd. Now, it is believed that a lot of these mammoths migrated. They moved south during the Ice Age. And we think that the type of fossils we found, we believe that there was a plethora of animals in this area in what we call Bone Valley, which is just south of the Ocala High in Florida. So you have a geological high, little raising of maybe 300 feet, coming down into a valley. It's called the Bone Valley. And that's where these fossils have been found, every one of them. And in this Bone Valley, we think that there were savannas in this area at one time. Savanna lands where grass grew prolifically and would attract many, many different kinds of animals. You know, the grazers like the mammoths and other kind of animals. And maybe then we would have the saber-toothed cat coming in. Well, as we looked at this kind of mammoth and all the mammoths coming in here over the savannas, it was from the Lewis Clark expedition that they actually found in the early 1800s along the Yellowstone River in Montana. They saw that there was great plains full of savanna land where many, many animals had migrated. Clark, in the Lewis and Clark expedition, actually recorded in his log, said, "I can't believe how many elk, deer, so many animals, buffalo, were in these plains This is what I perceive that could have easily happened. And by the way, many paleontologists in this area believe that we had all sorts of animals coming in here, enjoying themselves on the grass, the rich grass in the plains along the Bone Valley, where we found these bones in Arcadia, Florida. We're now looking at a giant shark. Now this is a tiger shark. You can see the teeth all lined about, and you can see the rows of teeth. Now, during the Ice Age, we had a shark much bigger than this, the Megalodon. And its teeth were very large. You can take a look. See the teeth right here? That's one tooth. And for every inch is 10 feet. So this one could have been at least 40 feet. They go up to 6 inches, so we could have a 60-foot giant, big shark, Megalodon shark. This is kind of a illustration of the tooth being layered, and these are real big teeth. So you get the idea that this had to be a gigantic animal. So we see giantism in the fossil record everywhere. We even see that the creatures like the giant sloth that walked around 18 foot tall. Right here I have a claw of a giant sloth, Armithium, who basically had claws that could stretch themselves out. So you can imagine this animal could have been in your backyard eating, the vegetation, and there he is with these big claws. We also have an illustration of the teeth. These are the teeth. They lacked enamel, so they can continue growing like a rodent's teeth. They would have to sharpen these things. So you get an idea that this animal had to be huge, not the sloths we're used to. This is 10 foot, 12 foot, go up to 18 foot of sloth material. Also, another indication of giantism was these armadillos walking around, giant armadillos. We have scoots of these things everywhere. When we dig fossils in the Peace River, the Ice Age area where we've been digging, we find lots of these creatures, and lo and behold, here's a scoot, and we have several bits of this scoot put together, and you can literally make it about this big to fit an animal about that size. So imagine a giant armadillo walking around about 4 or 5 feet in height. And so there are many creatures that we see, including this saber-toothed cat. This is the saber-toothed cat. Now the cat is formidable size. You can take a look at its skull. When it opens its skull up, it can move not 80 degrees or 90. When you open your mouth, you can only get so far. But this animal can literally bring its mouth 105 degrees. I mean, that's a big area it could reach. It also had these unbelievable teeth. Take a look at them. And so, walking around with teeth like this might be problematic for us, you see. Cats have big canine teeth. And so do dogs. You'll see them when they chew meat move to the side. So this creature, we believe, Ice Age creature in itself, the saber-toothed cat, roamed the area of the Peace River in Arcadia. This makes a great display of giantism in the fossil record. Giant cats, giant armadillos, giant sloths walking around, along with our giant mammoths.
Mainstream scientists can a lot of times claim that, hey, cool it off a little bit, presto, we got an ice age, no sweat. In fact, they believe in 50 ice ages in their what's called Pleistocene period, and they're either 40,000 years or 100,000 years, which are Milankovitch cycles. So all this is tuned to their beliefs about the astronomical theory of the ice age. But can they really explain it? Well, what do you need for an ice age? Cooler summers. Most areas are cool enough in winter, but you need cooler summers so that the snow and ice won't totally melt and continue building up year after year. And not only that, you need much more snowfall. You need a moisture source. And these two requirements act counter towards each other, because the cooler the air, the drier it is. And so if you find a cooling mechanism, where's the snowfall coming from? It dries it out more. And by the way, secular scientists are stuck with uniformitarianism, present processes of climate change to explain the past. And that's why they get into what's called the Milankovitch mechanism, which is slight changes in the Earth's orbit that are cyclical, caused by gravitational forces. For instance, the tilt of the Earth is right now 23.5 degrees, but it changes from 22.5 to 24.5 due to gravitational effects. And it cycles every 40,000 years. And so they think that many of the ice ages cycle because of that tilt. But that mechanism's so small, it has major problems. And if they can find the cooling mechanism, they just dry it out. And that's why there's over 60 theories on the origin of the ice age. And they still can't really explain it. Not only that, you got to get a climate change that not only lasts for one summer, it's got to persist for many years. Well, how much cooling do we need? A man did a computer study by cooling the temperature of Canada off by increments of 2 degrees centigrade. And he got his 1-inch snow line to pass through the summer into the fall. When he cooled off the temperature 12 degrees centigrade below normal, his 1-inch line was only in northeast Canada. But the ice was cooler down south of the Great Lakes. So you need a lot more cooling for the Great Lakes area, south of the Great Lakes. So I use Minneapolis as a good spot. They have an average temperature of 70 degrees Fahrenheit, but because summer sunshine is the main mechanism to melt snow, and they get a lot of it at Minneapolis in the summer, you need to cool the temperature off well below freezing to keep the snow there over the summer. In Antarctica, when the temperature warms to 14 degrees centigrade, Fahrenheit, you get net melting. And that'd probably be the case for Minneapolis, but I would be more conservative and say that temperatures have to drop only to 20 degrees Fahrenheit for the summer average. That's a drop of 50 degrees Fahrenheit for the ice to pile up in Minneapolis and many other areas along the edge of the ice sheet in North America. Where are they going to get a climate change like that? And if they do get a cooling, it dries the air out. Oh, big problem. That's why the ice age is a major, major mystery. Like J.K. Charlesworth said, Pleistocene phenomenon, that's ice age phenomenon, have produced an absolute riot of theories, ranging from the remotely possible to the mutually contradictory and the palpably inadequate. That's not saying much for their theories, but that was in 1957. And supposedly we know so much more now, right? Not really. U.S. News and World Report reported on the top 18 mysteries of science in 1997. Some of these mysteries are mysteries of their own making because of evolution, like that first one up there. Why should males exist? Why? Well, because they can only believe in one sex that reproduces asexually. You can't figure out whether there's a male and a female. And that's where our biblical worldview has the evidence hands down on them, because it simply says God made us male and female. But the Ice Age was one of the top 18 major mysteries of science. Top 18. And you can get more quotes. David All, glacial Lake Missoulian's humongous floods. Although theories abound, no one really knows what causes ice ages. And in Nature, 2008, perhaps the longest standing puzzle in the earth sciences is what caused the Northern Hemisphere ice sheets to come and go. They can't explain it. Can we explain it? Yes, we did. Tom quickly breezed through some of this. Anyway, it would fit in a transitional climate between the flood and the present climate, because the ice age was after the flood, because the evidence is on the surface of the earth, on top of flood rocks, scratched rocks that still haven't weathered out, and so forth. So we put it in a transitional climate, meaning the flood caused the climate change for the ice age. How? Well, the flood was a gigantic volcanic event. Maybe 1/3 of sedimentary rocks probably originated from volcanoes. So you had a lot of volcanoes going off during the flood. So after the flood, you'd have a shroud of volcanic dust and aerosols causing cooler summers over the land. The aerosol is a fine particle, 1/1,000,000th of a meter in diameter, a micron, that float up in the stratosphere, and they settle very slowly. So, and these cool the summers, because we know that volcanism causes reflection of sunlight back to space, causing cooler summers. won't affect the winters, won't affect the ocean water because of the large heat capacity of the ocean water. Also, the fountains of the Great Deep during the flood and all the volcanism that occurred would heat up the water. So you'd have warm ocean from top to bottom, pole to pole. You could probably take a swim in the Arctic Ocean right after the flood. What's the significance of warmer water? Well, especially at mid and high latitude, where the warmer water would be a lot warmer than the current sea surface temperatures. And you can evaporate a lot much more water into the air at warmer sea surface temperatures. For instance, at a temperature of 86 degrees Fahrenheit, you can evaporate 7 times as much water into the atmosphere as you can at a temperature of 32 degrees Fahrenheit, 7 times. And the effect would be the greatest at mid and high latitudes, right where you need it to be caught up into storms that dump rapidly on the land. And the mechanism will persist but wane with time. See, as the ocean cools, it evaporates less and less all the time. Finally, the ice reaches a maximum, and then finally you reach a point where it can't sustain itself and then it begins to melt. And we can time it, give a rough estimate of the time based on this the mechanism that caused it. Anyway, here's a quick schematic of the reflection from volcanic dust and aerosols. Also, since the volcanic dust and aerosols settle out anywhere from 2 to 10 years, depending on how high it reaches into the stratosphere, it has to be reinforced. So, but there's a lot of post-flood volcanism during the Ice Age. As Charles Rohr said, signs of Ice Age volcanicity and earth movements are visible in all parts of the world. We had tremendous volcanism after the flood to replenish the particles in the stratosphere. And it's sort of, this is a quick schematic at high latitude, mid and high latitudes, warm ocean, powerful evaporation, volcanic dust and aerosols in the upper atmosphere, cooling the land, and snow and sleet pile up on the land. So that's the basic model in a nutshell, a quick schematic. I'm gonna skip this. Oh no, I'm gonna go into that. How rapid was this ice age? Like I said, it persists, but we can time it. And we can time it by the cooling of the ocean mainly. And I'm gonna skip over my cartoon. But I had to, the way I work this is that to cool the ocean, and you got to add up the heating terms and subtract the cooling terms, and you get a net change in temperature with time. And so some of the cooling mechanisms are evaporation is 2/3 of the cooling, and then conductive heat transfer to the atmosphere is another. Solar radiation is a heating mechanism. So you add up all these, and you have to estimate how far the temperature of the ocean cooled before you reach glacial maximum. I figure it was about 10 degrees centigrade, representing from an average start of 30 degrees centigrade for the ocean, a drop of 20 degrees centigrade or 38 degrees Fahrenheit. And so I plugged it in that, and I solved for time. There's no way to be accurate with these estimates during the Ice Age, so I use minimums and maximums in this, they call it balance equation or a budget equation. And this is the range I got for maximum and minimums using outrageous variables to bracket the time. But the best estimate I figured about 500 years to reach glacial maximum. And you have to figure out what's the average snow depth, and then you got to melt it. So using mins and maximums for, did the precip fall over the ocean, or did it fall over the ice sheets or the non-glaciated areas, things like this. So you can see my range for the Northern Hemisphere, my best estimate by 2,300 feet for the ice sheets in the northern United States for an average. This is about 40% the thickness what the secular scientists claim, which means sea level, with the ocean evaporation drops to sea level, is 40% of what they believe. So we're talking about 165 feet versus their, about 300 feet. Antarctica, my estimate was about 4,000 feet. And to melt it, I use the same idea, the budget equation for the melting of snow and ice. Add up the heating terms, subtract the cooling terms, you get a change in temperature, change in time. But once you reach 32 degrees, then you can start melting the ice. And of course, in that equation, the main variable is what's called the albedo, the reflectivity, which can range tremendously over a snow and ice cover. So that produced most of my range at the edge, the periphery of the ice sheet. I got a best estimate of 70 years to melt it if it averaged 2,300 feet, which it didn't. It was thinner at the edge. And so 70 years for the edge, 200 years for the interior, total time for the ice age is 700 years. So this is an example where we use biblical variables, hold fast to the Bible, and use from different variables. We get 700 years for one ice age. We don't need 100,000 years. We don't need 40,000 years. That's a secular idea of the stretched out time scale. So that's generally how the ice sheet works. And was there more than one ice age? They claim, like I said, there was 50. I'm going to skip the cartoon. Anyway, in the journal Geology, you see, they used to claim there's one ice age in the 1800s. Then they saw 4. And everywhere for 60 years, they only saw about 4 ice ages. But based on the deep sea cores, where they now claim there's 50 ice ages, all that's been wiped out, even though they thought it was so accurate at the time. But in Alberta, well, a great place for the ice, they used to say from 3 to 5. Now they only say 1, as this article from the journal called Geology says. And glacial reconstructions commonly assume multiple glaciation hypotheses in all areas that contain a till cover. Till is a glacial jargon for glacial debris left over after it melts. There's evidence of just one ice age on the land. On the edge, there's complications where they can claim maybe more than one, but we know one ice sheet can produce these things by surging ahead, backing up, moving forward again, and oscillating at the edge. But when they look at these places, they always assume multiple glaciations. So they find a complicated area, presto, they have more than one ice age. But the evidence really is that there's only one ice age. So I think my time is about run out. I could say one thing about the mammoths. The ice age, the mammoths came from the area of the mountains of Ararat and spread through Siberia, but Siberia would be a lot warmer in the winter. And so a lot of animals could round there and across the Bering Land Bridge through Alaska and down the east slopes of the Rocky Mountains near where I live, kept open for early in the Ice Age because of Chinook winds, downslope winds. And so the mammoths all came through there and spread all over the United States. And they spread clear to Florida. Columbian mammoths mainly south, woolly mammoths mainly north, but there's a lot of overlap in the ranges. And so millions of them, which you can easily have in the Ice Age just by, if they multiply every 10 years, it doesn't take long for them to be in the millions. So, and they spread and ended up in Florida in a grassland climate, a different climate than you have there today, a grassland climate. So that's all I have, and I'll turn it back to Tom.
Thank you, Michael. I really appreciate that, Mike. I've read your books. I followed through when you, I think in 1990, I don't know when you came out with the model. When did you come out with the model? Was it 1990?
1990.
Yeah, I saw the monogram that was produced, and I thought it was amazing. Anyway, wonderful job as a creationist. As I said earlier, the model has been used by many creationists, many by Institute of Creation Research and others have followed through with this model. So we thank you so much for that.
You're
and
welcome.
being a meteorologist, it adds up to that because you understand all the conditions that went into that. So we, as Mike concludes, we have reason to believe because of the mechanisms of a worldwide flood to produce an ice age. The other thing is that the Bible had said that we would have a worldwide flood, and then the idea of movement with these land bridges would mean the Tower of Babel could have happened during this time, right, Mike? And we could have
Oh
a lot
yeah.
of movement of people through the different Bering Straits and so on.
Oh yeah. In fact, as they spread up into Europe, they lost their metal tools and had to use stone tools, live in caves during the lousy weather of the Ice Age. And so presto, you have your caveman.
There you go.
But he wasn't dumb, he was smart, and especially to survive in an Ice Age climate. So
You
this
can't beat
model
that.
explains caveman too.